This is lesson 1 on the basics of electric circuits. Now, as you all know, hopefully, that we do get a series circuit as well as a circuit with resistors in parallel. This specific circuit contains both. Now, to start off, let's have a look at the battery or the cell. This battery has 2 cells in it. Remember, the long part resembles the positive part and the shorter line resembles the negative part. So on the left hand side will be the positive side of the battery. That means that the electrons or the current will flow from the positive side to the negative side. So it will go down there. All right, now as you can see right at this point, that is where the path splits. And because the path splits and there's 2 possible ways to go, we can see that this part is in parallel. All right, so where the purple part is, that is where the current splits. It goes through the 3 ohm resistor and it goes through the 6 ohm resistor. And then right here at this little yellowish part, the circuit's current comes together again and it goes back to series where it moves through the 8 ohm resistor. So this circuit contains both resistors in series as well as in parallel. Now, the first type of question that they can ask in a circuit like this is to calculate the total resistance or the total effective external resistance of the circuit. So let's just have a look at the formula again. For resistors in series, the total resistance is resistor 1 plus resistor 2 and so on. For resistors in parallel, we say 1 over resistor in parallel, total in parallel, is resistor 1 over resistor 1 plus 1 over resistor 2. And then remember, when you go and calculate the total there, remember to swap the top and bottom again, get the reciprocal to work out the final total resistance. But we'll have a look at that just now. Okay, so these are the formulas for resistors in series as well as for resistors in parallel. Now, this specific circuit has both of them in it, as we just saw. So we will calculate both parallel and series. We will then add them together and we will get the total resistance of the circuit. Let's first work out the parallel resistance. All right, parallel resistance, as we know, is in the purple part. So the 6 ohm and the 3 ohm are parallel with each other. So we can say 1 over parallel is equal to 1 over 6 plus 1 over 3. Let's just get the common denominator there. Common denominator being 6. So it is 1 plus 2. So 1 over resistance in parallel is 3 over 6. But that's not it. We want resistors in parallel and not 1 over resistance in parallel. So we need to get the reciprocal. We're swapping top and bottom. We're swapping the whole thing around. So resistors in parallel is 6 over 3. And that gives us a final answer of 2 ohms. Remember your unit. And for resistance, our unit is in ohms. So this is the resistance in parallel. But we're not done as yet. We need to calculate the resistance in series as well, so that we can add it to the parallel resistance and we can get the total resistance of the circuit. So let's have a look at the resistance that we do have in series here. We only have the 8. And then we treat the final 2 ohm that we just calculated in the purple part as being in series with the 8 ohm. So resistance in series is equal to the 8 ohm plus the 2 ohm that we've calculated. And that will give us a final resistance of 10 ohms. So this is the very common question 1 type in any circuits to calculate the effective resistance, effective external resistance of a circuit. And this is how we can break it up. First calculating parallel resistance and then adding it to any series resistance. All right, that brings us to the next type of question that they can ask us. Now for any circuits, electric circuits, we are supposed to know the very important law of Ohm. So Ohm's law states, in short, if we have a look at the formula, that the potential difference is equal to the current times the resistance. So for us to be able to calculate the potential difference, let me just get a different color here. We can say the current, and once we have the current, we can multiply that to the total resistance to get the total potential difference over the battery. Or we can break it up into separate potential differences. All right, let's have a look. What do I mean? All right, so if, for example, we have a look at this part. Okay, for this part, we know that V is equal to 4 volts. We know that the resistance is equal to 8 ohms, but we do not have the current. Okay, so for a question like this, they can ask us to use Ohm's law to calculate either V, I, or R. But in this case, they gave us V, they gave us R. So they can state a question like this. Calculate the current that moves or flow through the 8 ohm resistor. And we then know that we need to use Ohm's law. Please also note that a potential difference or a voltmeter is always connected across, in other words, in parallel, and a resistor. Okay, it's never in series, only an ammeter is in series. And a voltmeter calculates the potential difference in volts, whereas an ammeter calculates the current. Now let's go back to our question. Our question stated that we need to calculate the current moving through the 8 ohm resistor when there's a voltage of 4 volts. So let's substitute 4 for the volts, the I is unknown, and the resistance is 8. Normal equations, we need to get rid of the 8, so we divide with 8 on both sides. So 4 over 8 is equal to I, and let's just simplify that. 4 over 8 is the same as a half amperes for our current. So 0.5 amperes flows through the 8 ohm resistor. All right, so we'll stop right here. And this was just an example to show you how to calculate resistance in parallel, how to calculate resistance in series, as well as how to use Ohm's law to either calculate your voltage, your resistance, or your current. Thank you for watching. Hope to see you in the next video.